everybody. Welcome to Cassandra Lunch 35. Today we're going to be talking, we're going to have actually Arpan demonstrate some data operations with Spark and Cassandra. And I'll actually also show a couple of other examples from the interwebs on how to do something like a different type of deletes. Akwi, thanks for helping produce this meetup. You can be a co-organizer if you're watching this after the fact. Reach out to Akwi, or you can just put it in the chat channel. We are part of a bigger community of data practitioners, very diverse. We'd like to have people from different backgrounds come and speak. Heck, you could be from South Africa, Brazil, Europe, Nigeria. It doesn't really matter, anywhere in the world. I'd love to have you come in and talk. Data Community DC is, as you can see, made up of several different groups. We are one of them, kind of incubated inside the Data Wrangler group, and now its own group as Cassandra DC. What we cover here, anything related to Cassandra, getting in data, getting out data. In fact, I'm going to be showing an example after Arpan goes on how to delete data from Cosmos DB. And guess what? It looks just like Cassandra. We don't have any new people, otherwise we would ask you to introduce yourself. Group rules, if you have a question, just ask it. Be polite or ask it in the Zoom chat. Our company, Anant, we help our clients design, build, and manage data analytics platforms based around Cassandra, Spark, and Kafka. This is the reason why we're partnered with DataStax, and they also sponsor this group. GW University also sponsors us with Event Space, which we haven't used in a little less than a year. We also have local sponsors in Chicago and DC who have given us venue space and bought food for us. Our organizational sponsors ensure that our nonprofit Data Community DC continues to function and puts on events. Let's see, do we have any new events coming up, Akwi?
No, not at this time.
Let's see. I think there's one next week. Yep. There's one next week. It's basically our weekly data engineers lunch, which is on Mondays. It's like this lunch, but it's broader in general data engineering, not just around Cassandra. So that's every Monday. You can also check out these videos online on YouTube, as well as Cassandra.Link, where we curate content, everything related to Cassandra, Spark, and sometimes Cassandra and Kafka. But basically, if it's related to Cassandra, we have it here. In fact, some of the links that we're going to show are going to end up in there. It'll be in the index. With that, I will hand it over. Actually, before I do that, I do want to show people what we've covered over the last 35 weeks. We talked about actually data operations in general a few weeks ago, more than a few weeks ago, a few months ago. And we alluded to using Spark scripts to be able to do things with moving data around in Cassandra. And so this is actually a follow-on to that talk. And Arpan has already published this blog post, which if you want, you can follow along. And there's another resource, but we'll update this blog post with the additional resource that I will show you as well. So Arpan, it's all yours.
Alrighty, let me go ahead and share my screen. All right, can everybody see my screen?
Yep.
So as Rahul mentioned, we're going to be covering data operations with Spark and Cassandra, kind of an extension of what we generally talked about a month ago. We're just going to be focusing on a couple specific topics, and obviously there's so many things you can do with Spark and then Spark and Cassandra. If you're not familiar with Apache Spark, it's a unified analytics engine for large-scale data processing, and it achieves high performance for both batch and streaming data. We're just going to be focusing on batching in using Spark shell scripts. And then they have a DAG scheduler, query optimizer, and a physical query engine. They have over 80 high-level operators that make it easy to build parallel apps. We'll be using the Scala shell, which is generally when you run Spark shell, that's the default one, but they also have Python, R, and SQL shells. They have additional libraries like the SQL and data frames, which we'll be using. They also have machine learning libraries, graph libraries, and also streaming libraries. But again, as we mentioned, we'll just be focusing on the SQL and data frame libraries. And you can run Spark in a standalone mode, or you can run it on a container technology like Mesos, Kubernetes, but we'll be running it in a local standalone mode with one master and one or the master is obviously, but then one worker node. And we'll be focusing on connecting it with Cassandra, but there's a ton of other connectors that Spark can talk to. All right. And then in the demo portion, what we're going to go over is we're going to read from one table in Cassandra using Spark. We're going to transform that data, and then we're going to create and write to a new table using that transformed data. And then we're also going to cover deleting data. As Rahul mentioned, there are different ways to do it. We'll just show you a couple methods of deleting data with Spark and Cassandra specifically. And then if we have time, we'll talk a little about data migration across clusters, and we'll show you a couple of examples of code snippets that you could potentially use to do so. All right, we'll go ahead and get started with the demo. I have all of these commands already written out. As Rahul mentioned, there is a blog post published on our blog, blog.anant.us, and then the link will be available on this YouTube video when it goes up. And you can just copy and paste as it's written out, which I'll be doing, but I'll talk through the steps as we go along. All right, so we're going to be using, as I mentioned, local Spark. I already have it on my computer, and then we'll also be using Apache Cassandra in a Dockerized environment. So we are first going to start by getting our Cassandra container running. So we're going to do that by running docker run. And we're going to name our container Cassandra. We're going to expose the 9042 port, and we're going to use the latest image. All right, and it's just going to take a couple seconds to get started. While that happens, I'm just going to copy the next command, which is going to be executing or starting the CQLSH terminal within that specific Cassandra container. So what that command looks like is docker exec flag it Cassandra, which is the name of our container, and then CQLSH, which is just the command to open up the terminal. All right, and then now we're in. So just to do, we're going to start, just to start, we are going to create one very simple key space called demo with a simple strategy and a replication factor of 1. And then we're going to say use demo. And then within there, we're going to create a table. And this table is going to be called spacecraft journey catalog. And it's going to have a couple of different columns. So there's going to be a spacecraft's name, the journey ID, the start time, the end time, is it currently active or not, the summary of why that journey was made, and then the primary key is made up of the partition column, which will be the spacecraft's name, and then a clustering column of the journey ID. And then after that's made, we're just going to confirm that it's there. So we're just going to do a tables, and we see our table. Now we're going to insert about 1,000 records into it. So I have this data.txt file that's available on the blog post. I'm just going to go ahead and open it up real quick, copy and paste all the commands into the CQLSH terminal, and it's just give it a second. It's 1,000 records, but it's pretty fast. While that's going, I'm just going to talk about what the next step would be. So the next step is we're going to start Spark, and you can use Spark. I think the latest version is 3.0.1. I think locally I have 3.0.0. This will work on both versions. So which version you choose to download, up to you. But I'm just going to open a terminal. Just going to expand it because we're mainly just going to be doing everything within the terminal. So that's all we really need to see. All right, and so here I'm going to cd into my Spark directory. And when we're starting our Spark directory or starting our master node, it's going to be /sbin. Again, all these commands are available for you in the blog post. It's going to be start master.sh. And once the master is run, I'm actually going to open a new, because we're going to need the Spark Masters UI. So we're going to go to localhost 8080, and that's where the Spark Master UI is available. And when you're starting a worker node, you need the master URL so that way it knows where to point to. So if all we need to do is just copy and paste this URL, and if we go back to our terminal to start a worker node, it's /sbin start slave.sh, and then we paste in the master URL. And after that's deployed, we are going to go back to the UI and just do a quick refresh. And now we see our worker node that we just started. So now our worker node is connected to our master, and we can get started with the rest of the demo. So now we're going to start the Spark shell. And when we start the Spark shell, we're going to need a couple specific things. We're going to need the package, or we're going to need one package, specifically the Spark Cassandra connector that DataStax has made and is available. You can find it on GitHub. And depending on what Spark versions you're using, your Cassandra versions you're using, they have a compatibility chart that you can use. So we're going to pass that package in. And then we're also going to pass in the master URL. So again, what we just copied and pasted from the Spark UI. We're going to pass in a couple different conf settings. So we're going to say our host is local, so 127.0.0.1, and then our port, which was 9042. And then we're just going to pass in an optional SQL extensions. You don't need to, but it's just what I have. So I'm just going to copy and paste this into our running Spark terminal. And so again, we're doing .bin Spark shell, which again, as I mentioned, the default Scala version. And then we're passing in the packages. So we're passing in the Spark Cassandra connector. That's going to get downloaded as a shell starts. And then we're passing in the master URL, the connection host. So our Cassandra is running at local 9042. So our host and our port. And then again, this optional package that I'm just passing in. As this runs, we'll see all the things. And then we'll see that our modules are getting downloaded from the package that we passed in. And just give it a second, and it should go ahead and get started. All right, great. So now what we need to do is pass in a few different imports, so that way we can utilize specific functions when we're running the shell scripts. And I'll show you what these look like when I paste it. So we've passed in 4 packages. So we're saying import the org Apache Spark SQL functions. When you see this period underscore, that just means recursively have everything. You can do like spark.functions dot a specific function if you only need a specific function. But we're just going to go ahead and just take everything. So we're just doing a period underscore. And we did that for each of the options. So we also passed in the Spark connector, the SQL Cassandra, and then the SQL or the Spark connector CQL. So now we're going to cover how we can start by reading data from that table we created in Cassandra. So there's 2 methods that I have. Obviously, there could be others, but there's the load method and there's also the catalog method, and I'll go through both of those. So when we're starting with the load method, I'll go ahead and we're going to load our data as a data frame, and that's going to look as val_df, which is arbitrary variable we're creating, and we're saying Spark read in Cassandra format. This Cassandra format function is shorthand, so if you look online, there's other versions where you can say .read and then you pass in different types, so like org, Apache Cassandra, org, different types of databases you're using. But this Cassandra format is shorthand that we can use, and we're saying use the spacecraft journey catalog that we created in the CQLSH terminal. from our key space demo and load it. So if we want to see, sorry, now we're going to do some transformations on that now that we have it. So if you noticed in our table that we made, I'll just do a describe. Spacecraft journey catalog. You see how we have this end time and start time? Say we wanted a table that had the duration of each journey instead of just the end time and start time. So this duration number could be used for BI analysis. It could be used as just a display, but there's no calculated version of it in the data that we used. So we can use Spark to do it and do data manipulation and create this table and write it into Cassandra. So we're going to go through that process. So we have now loaded that spacecraft journey catalog, the initial table, into Spark. So we are going to create a new data frame. And there's also two methods we could use here. We can use a temp view, or we can use the select method, and we'll go through both, but we'll start with the select method. So when we're saying val df, we're saying from the initial data frame we loaded into, select the columns summary, journey ID, and then the date difference function. So what this date difference function is doing is essentially calculating the days in between the start time and end time that we're provided with, and it gives us back a number, and we're saying that column is now called duration in days. So if I do new df.show, we should, let's see. Oh, new df.show. Okay, sorry about that, typo. So when we get back, we're going to get back this tabular format of data where we can see this data that we transformed. So instead of having an end time and start time, we've calculated the duration in days for each journey. So this journey had a summary of tested lunar mod, whatever, and it has a journey ID associated with it, and the duration in days. So instead of having when did it start, when did it end, we now have a clear way of just seeing how many days did it take. And then you can use BI analysis or whatever else you need to do with it. But Spark just made it really, really, really easy just to do data transformation on data we have in Cassandra. So another way we could do this and get this same data frame is using a temp view. So what we could do is take that initial DF that we set, and we say create or replace a temp view. When you set it as a temp view, you can now do SQL on top of it. So what we'll now do is redo our val new DF, and we'll use Spark SQL instead. Excuse me. So we're saying val new DF, spark.sql. And so if you notice, the syntax is almost the exact same when we're doing the select method. But now when we're using Spark SQL or spark.sql, we're doing literally just SQL, no column identifiers, no commas, parentheses, or commas, and other etc. stuff that we need in the select method. All we need to say is just pass an SQL query that says select summary, select journey ID, date difference as duration in days from df, which we set as a temp view. And if we now do val new df.show, it'll give us back the same exact data. And now we can now cover the catalog method. So this was the load method where we loaded into df. Now we're going to use the catalog method to also read on data. So when we're setting a catalog, we pass in a conf. So you can set config properties on Spark in the shell at a later time. You could also do it at the very beginning when you started Spark shell, because remember we had the --conf Spark connection host. This is the same exact thing, but we're just doing it within the shell. So when we do this, we're saying set our catalog as Cassandra, and we're using this from the Spark Cassandra connector. And so now using this catalog in the database key space table, database period key space period table format, we can use SQL and get back our data that way. So we don't need to do a select method. We don't need to do a temp view. We can just straight up just make a data frame using Spark SQL. And so when we do this, what we're doing here is we're doing val new df, spark.sql, select summary, journey ID, date difference. So it's the exact same as what we did after we created the temp view. But what we're doing here is we're using the catalog, which is the database, demo, which is our key space, and then our table. So it's that database key space table method. So we've taken out a couple steps and we've been able to do it within one command. So when we run this and we run our show, we're going to get back the same exact data. And those are just a couple of different ways where we can just read data from Cassandra. And now we can move on to creating a table from what we just did. So for creating a table in Cassandra using Spark, all we need to say and use is the create Cassandra table method. And I'll show you what that looks like when I paste it in. So what we're doing here is we're saying use that new DF, so that data frame we just created here, create Cassandra table, and then in our key space of demo, make this table name. So you can arbitrarily name this whatever you want, but we're naming it as duration by journey summary. And when we're doing that, we're saying our partition key columns part of the primary key. So our partition key is the summary. So that's what's going to be our partition. And then we're going to have a clustering column of journey ID. And if we go back into our CQLSH terminal and we do describe tables again, we should now see our new table. So essentially what that create Cassandra table did was it took our data frame and used its named columns and was able to create a table within Cassandra. So now if we do describe duration by journey summary, we should be able to see summary text, journey ID text, and our duration and INT. So it picked it up from our data frame. And then we're saying our primary key summary, which it looked at for our partition column that we set, and then our journey ID, which we set as a clustering column. So it was that easy just to create a table in Cassandra using Spark. So now if we want to write to it, it's a very similar thing. So we just take our data frame that we used, new DF, and then we're going to do a write, and then in Cassandra format. So again, remember how we did read Cassandra format? It's the same thing. So if it would be write Cassandra format, just shorthand, you could use other org dot, etc. But Cassandra format, just because we're using Cassandra, and then we're going to write that into that new table we created. So duration by journey summary, and then in our key space of demo, and then we're going to set it with a mode of append, and then finish it with the dot save. And then if we go into CQLSH, I'm just do a quick clear. It's still going to be running, but we're just going to do a select all from duration by journey summary. And now we're getting back our data. So we have the summary. It's a little lopsided in terms just because of my size, but we have the summary. So spent almost 3 months in space. We have our journey ID, and then we have the duration of that as needed, or as calculated, apologies. And then we could see our partitions. So we have this set of partitions, which all have the same partition key value, which was mere crew rotation and resupply, but they all have different journey IDs, and we have that set as a clustering column. And then same thing with ISS crew rotation, again. So we have now created a table using transformed data that we loaded from an initial table in Spark. So now we can talk about how do we delete this data using Spark and Cassandra specifically. And then I will pass it to Rahul to talk about other methods we can delete data in Cassandra with. All right, so now we're going to cover 2 methods for deletions. We're going to cover one method, which would be deleting an entire partition. And then another method is deleting a partition, but having an extra condition in the where clause. So essentially what we're going to do here, and the first one is we're going to delete the entire partition that has ISS crew rotation. So if we just do an arbitrary select count from duration where summary equals ISS crew rotation, and then there's a period. we got 40 rows. So when we do this delete, we ideally should get back a 0. So going into Spark, if I paste this, so what we're doing here is we're using Spark context, and then we're using the Cassandra table method. So we're saying, look at this table. So from our key space demo, and then our table duration of journey summary, and then have a condition. So where summary equals ISS crew rotation, so what we just used, and then use that and delete it from Cassandra using our key space in our table. So if we go back to our CQLSH terminal and we rerun the count, ideally we should have a 0, and we do. So we've deleted an entire partition using Spark in Cassandra. So that's how easy it is. It's just one line as needed. And so now what we'll also do is we'll take this, bring supplies to Space Center. So we have a good amount of records with the variance in duration days. Say we want to delete any record that has a duration day of less than 200. So we just want to see outliers, or we just want to delete everything else. So we want to keep only a certain amount of records. So we see we have 1 over 200, 2 over 200, 3 over 200. So we have records that are over 200. So we should see the count obviously decrease because there's a good amount that are under 200. So if we go back into Spark, it's going to be the same exact command we ran here, but obviously our summary is going to change. So our summary is now going to be bring supplies to Space Center. And then also our where clause is going to have an and in it. So when we run this, we should get back in our Cassandra CQLSH. If I just run a select all, we now see, or we don't see any more bring supplies to Space Center. Or we do, sorry. We do see some. And we see that their counts are only over 200. So just to make this a little bit more clear, I'm just going to do a select all from duration where summary equals bring supplies to Space Center. All right, so we now only have 4 records left, and each of these records has a duration greater than 200. So we were able to use Spark, delete within a partition specifically set to certain conditions that for us was duration in days was less than 200. If we wanted to flip it and delete everything greater than 200, it would be the same thing. We just have more records, but under 200. But those are just a couple methods for deleting with Spark and Cassandra. But there are other options. And as Rahul mentioned, he has a couple things from the internet, and I will pass it over to him.
I'm on mute. Thanks, appreciate it, Arpin. Yeah, as I mentioned, I'll share my screen real quick. As I mentioned earlier, that I did want to quickly show how to use a slightly different way. It's very similar to the way you did it, but what I would like people to see is that you can combine the stuff that you did with like data frames, reading it, and filtering it using data frame filters, and essentially removing data using Cassandra's Java driver, meaning it's not talking via Spark. So I'll kind of outline the steps, right? So basically, this is a link that I'm gonna show the code, but really what we're doing here is we're saying, first of all, let's connect to Cassandra, right? So if you are using Cosmos DB or Cassandra or Skilla, you can use the same Spark driver to connect. So it doesn't really matter what type of quote Cassandra you're using, as long as you're using the Cassandra Spark connector, right? So it's about the same. It's just you're gonna have different information. The next thing in this case, it kind of creates some random data, right? What Arpin showed you guys earlier is he just imported data via insert statements, but it shows that. And then what we do is we load data. What we do is we filter the data set via data frame. And there's a couple of ways to do that, but in this case, we're doing the fluent kind of Spark domain-specific language, whereas you can also just do a select query, right? The way that you selected your data, you could do the same way, but in this example, it's using the data frame and it does a filter on that data frame. And then finally, it does what's it iterates too, right? So using the Java Cassandra client, it basically connects to a different, well, basically the same information. It's using the same Cassandra connector, but it's connecting and it's executing a direct CQL query. It's not doing a Spark operation. So I wouldn't say it connects to a difference because it's the same cluster, but instead of using Spark to delete data, it uses CQL to delete data via session.execute. So why is this useful to know how to do? Well, you may want to scan one table, get particular data that you want to delete from that one table. But what if you do have other data that's related to that data? Just because Cassandra is a non-relational database doesn't mean that you don't have the same customer ID in different tables, right? So what this can do is it can separate the concern. You're using Spark to do the filtration, and then you're just using the power of Cassandra to distribute the delete, because you can set delete to any node, and that node will then figure out where to go. In fact, Spark itself will know with the partitioner in the intelligent driver, it'll know where to send the delete statement. So you're able to essentially execute deletes without having to parallelize in Spark the deletes. You're letting Cassandra do the deletes in the best way possible that it can do, which is all asynchronously, right? So we take a look at the example here. Zoom in a little bit, and this link I'll put in the chat so you guys can save it. It's also on. It's going to be on Cassandra.Link by tomorrow. I just saved it to the knowledge base. So the only thing different that it's doing, maybe a little special, is that Cosmos DB has its own Cassandra library for multiple retry. Other than that, this is all native Spark. As you can see, it's actually using the DataStax Spark connector. There are some things here related to throughput, right? And if you ever worked on Spark, you'll note that at some point you need to tune these input and output parameters because Spark doesn't do everything the same way for every job, because the data coming in and data going out is not always the same, and so you have to tune some things. Sample data generator, this is pretty standard. It just makes a sequence of tuples and it just adds it into the data frame, and then it writes it to Cassandra. All right, so here we go. Getting data, right? So we're doing spark.read, getting the data frame for this particular table, and then we do a filter. Okay. Now you could also do a Spark SQL query and save it into a data frame, like select star from this, right? Meaning you don't have to get the whole table. You could just get the columns that you need, right? You could just be like, I only want my primary key because that's what I need to do deletion on the data. You could just do that, right? That makes it a little bit more efficient. This is just to show you, the data frame execution plan. This shows you what the data is there before, and then here's the for each. You got your connector, right? You're saying, here's my connector using the same Spark context up over, where did it go? It actually, it is using the same Spark context, which is SC is a default one. And then for every one of these, right, for every partition, right, it's going through and using the session, and for every partition, for each, essentially each partition of work, each partition of data, it's going and getting the first column, although you can also name specific columns and get it, but in this case, it's just getting the first one. And it's saying delete, and then it executes a delete. Now, you could construct 5 different delete statements here, append them, and just say delete. Okay. So there's different ways to do deletion of data. This one, the reason I like it is that, if I'm using like DataStax Spark, essentially, apart from importing some of these, all I need to do is like the query and this. And actually, I've gotten it down to where it's like the select clause is here in one Spark SQL, and then this is the deletes. And I can just have little snippets of it. So if I have to clean out data, when I'm doing development, I can just go in there, copy, paste, run, Spark shell. It's done. Cool. Yeah, that's it. Nothing more special than that. I mean, you're basically doing the same thing except this last part, right? Yeah, that's all. Cool. Awesome. Well, we covered, some of the most basic stuff we can cover with Spark and Cassandra, which is how do you, manipulate data and how do you delete data. More to come. There's a lot of cool stuff you can do with Spark and Cassandra. But I think in the next talk, we'll maybe go deeper into other ways to do data operations. There is a tool that we use a lot of, and I'll see if I want to kind of show how to use it next week, but it's actually made by Skilladb. And Skilladb is a competing product to open source Apache Cassandra and a competing product to DataStax, but they want people to leave DynamoDB and Cassandra and come to Skilla, so they've made migration tool. And what I love about this migration tool is that you can just say source, right? Target, you give it the information, you give it some specific, tunings related to execution and validation, and you just say run. And you can run this on any Spark, right? It doesn't really matter. And the thing is that it's using, even though it can talk to Skilla as a target in this example, right? It doesn't matter. You could change this target to Cassandra because under the hood, it's using the same Spark Cassandra connector, right? If you look at the code, you go in here, it's using the same connector. That's all. Cool. All right. Awesome. Well, any questions, by the way, before we call it a day? Ooh, seeing none. You guys have a wonderful rest of the week, and we'll see you next time, same place, same time. Take care.
Thank you.